Hello everyone, welcome to this session on using Numpy functions. Before learning Numpy functions, let us understand why Numpy is important. Numpy stands for Numerical Python. It is one of the most widely used Python libraries for numerical computations and data analysis. Normally, Python provides lists to store data. However, when dealing with large amount of numerical data, Python lists become slower and consume more memory. NumPy solves this problem by providing a special data structure called an array. NumPy arrays are faster, more memory efficient, and support powerful mathematical operations. In this lecture, we will learn how to create NumPy arrays, understanding different dimensions of array, and the usage of placeholder functions. Let us begin with creating n-dimensional arrays. So first we are going to discuss about creating n-dimensional array. NumPy uses a special data structure called ND array, which stands for n-dimensional array. Here n means array can have n number of dimensions. The function used to create an array is np.arrayof. The table represents different types of arrays. A one-dimensional array, which it is called a vector, and it is created using a single list. Then a two-dimensional array, which it is called a matrix, and it is created by using a list of lists. Then a three-dimensional array, which it is called a tensor, and it is created using a multiple two-dimensional list of arrays. As a dimension increases, the data structure becomes capable of storing more complex informations. Let us see the examples of each type. So first we are going to see about one-dimensional array. Here we can have an example of one-dimensional array. Here the code uses np.arrayof function. So in this function we are passing a single list of value because here only one list is provided. So NumPy creates a one-dimensional array. See the output. So it will be creating a one-dimensional array, all elements in a single row. A one-dimensional array, which it is also called as vector. Notice that data stored in a single direction and there are no rows or columns. So this type of array is commonly used for storing student data, marks, monthly sales figures, temperatures, or any linear sequence of value. The important point to remember is that whenever a single list is passed to np.arrayof, NumPy creates a one-dimensional array. Next, we are going to discuss about two-dimensional array. Now, let us create two-dimensional array. Observe the code carefully. So here in np.arrayof function, so here we are passing a list of lists. Each inner list represents a row. For example, the first list of items represent first row, second list of items represent second row, third list of items represent third row. So the output displayed here is it consists of a table, like a table, that is it consists of rows and columns. Because of this tabular structure, a two-dimensional array, which it is called matrix. Matrices are widely used in data analysis, spreadsheets, machine learning, and mathematical computations. Next, we are going to discuss about three-dimensional array. So see here in this code, in np.arrayof function, so here we are passing a multiple two-dimensional arrays so that are grouped together. Each two-dimensional array become a block, which means this is one block, this is another block. So therefore NumPy creates a three-dimensional array. So output also displayed like a block by block. This is first block, this is second block. So three-dimensional arrays are commonly used in image processing, video analysis, and artificial intelligence application. And one more thing, to understand better how three-dimensional arrays are, means imagine like a stacking multiple matrices one above the other. So see this example, stacking multiple matrices one above the other. For example, a color image can be represented using a three-dimensional array consisting of height, width, and color channels. Now we are going to see about placeholder function. So far we created array by using a known value. However, in many situations we may not know the values beforehand. We may only know the size of the array that we need. In such cases, NumPy provides placeholder function. Placeholder functions automatically generate array with default value. These functions help us initialize arrays quickly without manually entering every element. Let us look at some commonly used placeholder functions. So these are the commonly used placeholder functions which are available in NumPy. np.empty of, np.zeros, np.ones of, np.i of. Let us discuss one by one. So first we are going to see about np.empty of. So this function, it creates array without initializing array. Sometime it will be displaying by using a garbage value. It is based on our terminal or whichever configuration or whichever hardware we are going to use, so based on that. Okay, so by using a np.empty_of function, we can create a one dimensional, two dimensional and three dimensional based on the passing of elements. So np.empty_of 3, so 3 which means a single list of element, it will be containing a 3 element. So it will be displaying a 3 element, 3 uninitialized values it will be returning. So np.empty_of 3, which means it will be creating a two-dimensional array which consists of 3 rows and 3 columns. All will be displaying without initializing a value, or sometime based on sometime it will be fetching a garbage value. Then np.empty_of 3, which means 3 blocks of 3 rows 3 columns. It will be filled with uninitialized value or sometimes some garbage value. So next function will be np.zerosoft. So np.zerosoft, which means it create arrays filled with 0. See the example here, np.zerosoft3, which means it represents a single row of element containing 3 elements, because here we are representing 3 all filled with 0. If it is np.zerosoft3, so it will be creating 3 rows and 3 columns all filled with zeros. Then np.zerosoft3, which means 3 blocks of 3 rows 3 columns it will be creating all filled with 0. The next placeholder function is np.onesof. So np.onesof, which means it create array all filled with ones. So np.onesof3, which means it's a single list of 3 elements all filled with 1. If it is np.onesof3, which means it's a two-dimensional array consisting of 3 rows and 3 columns all filled with 1. If it is np.onesof3, which means 3 blocks of 3 rows 3 columns all filled with 1. Then the last function will be np.iof. So this np.iof, so this placeholder function, basically it created 2D array with ones on the diagonal and zeros elsewhere. That is ones on the diagonal and zeros elsewhere. This is np.iof function. So next we can understand using the placeholder function by using one dimensional array how it will be, two dimensional array how it will be, and three dimensional array how it will be. So first we can see the placeholder function. By using a placeholder function, how we can create array for one dimensional array, we can understand by using this example. So whenever we will be working with the NumPy, we have to import a NumPy module by using this statement, import NumPy as np. Okay, so np.empty_of3, which means so it will be creating a 3 single list of elements with uninitialized value. Sometime it will be having a garbage value. So based on our hardware or based on our terminal what we used. The next one is np.zerosoft3, which means it will be creating a single list of 3 elements all filled with 0. Then np.onesoft3, which means it will be creating a single list of 3 elements all filled with 1. Then next function is np.fullof3, so np.fullof, which means it create arrays filled with specialized value. So np.fullof3, which means single list of 3 elements, but all 3 elements filled with the special value 2. So this was the output for np.fullof. Then np.randomof 3, which means so a single list of 3 elements, some random elements will be created. So these are all the placeholder functions for one dimensional array. Now we can discuss placeholder function for two dimensional array. So if it is a two dimensional array, then we will be representing by using rows and columns, right? So np dot empty of 3 comma 3, which means so it will be creating a two-dimensional array consisting of 3 rows and 3 columns. So this was the output. Then np dot zeros of 3 comma 3 means so it will be creating a two-dimensional arrays of 3 rows 3 columns all filled with 0. Then np dot ones of 3 comma 3, which means it will be creating a two-dimensional array of 3 rows 3 columns all filled with 1. Then np dot full of 3 comma 3 comma 2, which means it will be creating a two-dimensional array of 3 rows 3 columns filled with a specialized value 2. Then np dot I of 3, which means it will be displaying a 3 rows 3 columns a list of array. So here diagonal will be filled with 1, rest of the thing will be 0. Then np dot random of rand of 3 comma 3, which means so some 3 rows and 3 columns of value, some random value it will be filling. Next we are going to see about placeholder functions for 3-dimensional array. So if it is a 3-dimensional array, the representation will be blocks comma rows comma column, right? So np dot empty of 3 comma 3 comma 3, which means first 3 represents blocks, second 3 represents rows, third 3 represents columns. So 3 blocks of 3 rows 3 column, which means all the 3 blocks it will be consisting of 3 rows 3 column. So this will be the output. So this is first block, second block, third block. See all the 3 blocks it having 3 rows and 3 columns. Then np dot zeros of 3 comma 3 comma 3. So the same thing, it will be creating a 3-dimensional arrays of 3 blocks. So each of the blocks it will be consisting of 3 rows 3 column all filled with 0. So this was the output. Then np dot ones of 3 comma 3 comma 3, which means 3-dimensional array will be created. So all blocks, that is all the 3 blocks, it will be creating 3 rows and 3 column all filled with 1. Then np dot full of 3 comma 3 comma 3 comma 2, which means that is it will be creating 3 blocks of 3 rows 3 column all filled with the special value 2. See the output here. Then np dot random dot rand of 3 comma 3 comma 3, which means so some 3 blocks of 3 rows 3 columns, some random value will be created. So this was a placeholder functions for 3-dimensional array. So up to this I am completing this session. In next session I am continuing the numpy function. So in that we can discuss about numpy attributes and some commonly used function for creating numpy arrays. Thank you.